Okay, we've all seen AI do these incredible things, right? You show it just a couple of examples in a prompt, and boom, it seems to just get it. This amazing ability has a name. It's called in-context learning, or ICL. And today, we're going to pull back the curtain and find out how it really works.
So let's just dive right in with a classic example. The model sees two examples of English to French translation. We give it red becomes rouge, blue becomes blue. Then we ask for a third, green, and it correctly spits out there. It honestly looks like it learned French in a split second. Feels kind of like magic.
And this is the million-dollar question. Is it truly understanding the concept of translation, or is it just a masterful mimic? To figure this out, we're going to go on a little investigative journey, following the clues from a massive research paper by Adran de Wynter that put this very question to the ultimate test.
So our first stop on this journey is to figure out what real learning even means. Because in the world of learning theory, it's not just about getting the right answer. It's way deeper than that.
So what's the gold standard for real learning? Well, it all comes down to this one word: generalization. It's the ability to take what you've learned from a few specific examples and apply that core knowledge to totally new problems you have never, ever seen before. Think of it like this. You've got two students. The crammer, well, they memorize the answers directly from the study guide. They'll ace any question that's word for word from their notes. But if you ask them the same concept in a slightly new way, they're totally lost. Then you have the scholar. The scholar understands the why behind the answers. They grasp the underlying principles, so they can solve any problem that tests that core concept, no matter how you phrase it. Real learning, that's being the scholar. So, armed with our definition of real learning, the scholar versus the crammer, the researchers set up the ultimate final exam for these AIs. The whole goal was to find out, once and for all, which type of student are they really? And when I say ultimate final exam, I am not kidding. We're talking about a massive, rigorous stress test. The researchers analyzed nearly 2 million predictions for each and every AI model they tested. This was all about pushing them to their absolute limits to see where they'd break.
Now this is where the experiment gets really, really clever. They tested all the big models on a bunch of complex tasks using all sorts of prompts. But look at that last row, data types. This is the key. They didn't just test the AI on problems that had seen before. That's the in-distribution data. They threw in curveballs, what the researchers call out-of-distribution data. These are the surprise questions, specifically designed to separate the crammers from the scholars.
All right, the exam is over, so what did the results actually show? Well, this is where we start to see some really surprising cracks in the AI's armor. Okay, first up, that whole idea of few-shot learning, where the AI just needs a couple of examples to get it, this study pretty much debunks it. To get peak performance, the AI needed a whopping 50 to 100 examples. That's not a quick glance at the study guide, that's some serious late-night cramming. And this chart shows the biggest reveal of all. Just look at the difference. On familiar data, the stuff from the study guide, the AI does great, scores an 85%. But the second you face it with new, surprise problems, its performance absolutely plummets, all the way down to 55%. This is classic crammer behavior. Aces the practice test, but completely falls apart on the real exam. And then there's this really weird inconsistency. On one simple task, the AI is a total genius, scores almost perfectly. But on another, equally simple task, it's just completely stumped. That's a huge red flag. It tells us the AI isn't really learning the logic. It seems like it's just getting lucky with some patterns and not others, which helps explain why it can feel so brilliant one minute and then spout complete nonsense the next. Okay, so we've gathered all this evidence from this massive experiment. We've seen the need for tons of examples, the plummeting scores, the weird inconsistency. So, what's the final verdict? Is in-context learning actually real learning?
The verdict is in, and it's crystal clear. The AI isn't becoming a scholar of French translation or logic puzzles. No, it's becoming a master forger, an incredibly sophisticated pattern matcher that can mimic the surface of the examples we give it without ever understanding the deep structure underneath. So why does any of this matter to you? Well, for one, this research finally explains that frustrating inconsistency we've all experienced. It proves that the performance you get depends heavily on both the quality and the quantity of the examples you feed the AI. It also shows that even those advanced prompting techniques can be surprisingly fragile. It is a form of learning, yes, but it's the learning of a mimic, not a true student. It's all about the surface, not the substance. And that leaves us with a final and, I think, crucial question to ponder. Knowing that AI is an incredibly powerful pattern matcher, it forces us to think a little differently. It means we have to be so much more careful and intentional about the examples we give it, because it will learn exactly the patterns we show it, for better or for worse. The magic isn't gone, but now we understand the trick.